بسم الله والصلاة والسلام على رسول الله. Inshallah, in today's lecture, we will continue talking about Windows file system. So, if you can remind me about the main aspect that we covered last time, can anyone tell me what did we cover? Anything, like what are the main things that we covered last time or last session?
كأن كان عندنا نوعين من الفايل سيستم اللي هو النيو تكنولوجي فايل سيستم.
Yeah, what is, yes?
في نوع
Yes.
ثاني بعد اللي هو أتوقع ال FTP كأنه.
FAT, NTFS, these are different types of file systems. Perfect. So what is file system? When I say file systems, what is file systems? What is file systems?
The way you organize the files inside the hard disk.
Perfect. The way, how would I organize, store data on the storage medium? Perfect. Okay. So last time we reached a point where we mentioned something related to the file slack and RAM slack. And we mentioned that if I would like to store any file, I might reach some like areas that is that's free, nothing utilized within this area. So I will show you here. Last time we covered like we stopped at examining FAT disks, right? We stopped at here. So we mentioned that if I would like to store any file, I will store files in a cluster because this is the measurement in terms of storage. They usually consider the clusters, right? Perfect, exactly. When we store any file, we will store it in a cluster, not a sector. This is very critical and very important thing to know throughout the whole semester. Now, this, if I save files in clusters, this will result in two things. The first one, something called a drive slack. A drive slack is unused space in a cluster between the end of an active file and the end of the cluster. So we will see an example what is drive slack. A drive slack is kind of unused space within the cluster. Maybe the file is like, let's say the file is 2 megabyte and the cluster is 5 megabyte. This means there are 3 wasting of megabytes, right? So if the cluster is 5 megabyte and my file is just like 2, this means I will kind of waste extra 3 that is stored, allocated, but it is not utilized. This is called drive slack. A drive slack is actually divided into two things. The first one is RAM slack and the second one is file slack. What is the difference between file slack and RAM slack? I will show you here. So I will show you here an example, just a quick example. Let's say that I have a file and this file is 100 bytes and number of sectors per each cluster is, let's say, 2. Okay? And the sector is actually 512. Are you with me? One sector is 512 and I have 2 clusters. This means how much I have per cluster. What's the cluster size?
124.
Yes, 124, because I will multiply 512 by 2 and it will give me 1024. This means I am storing actually 1024. However, I just have 100 file. I will have a lot of empty spaces. Let's see how it will be look like. It will show you something like this. This is the first sector and this is the second sector. This is the first sector and this is the second sector. Now, all of them in one cluster, because one cluster, which is 1024, is sufficient to store the whole data. But actually, there are some empty spaces. So first of all, I will take the first sector, which is the 512, and I will take just only 100. If I take 100 from 512, how much will be remaining?
400.
Exactly. 412 called RAM slack. RAM slack is the empty space between, it is the unallocated space, okay, between the end of the file till the end of the sector. So this is the RAM slack. It's 412. So what about file slack? File slack is actually the unallocated sector. The sectors, it's like the sectors that are not utilized within the file storage. So how many sectors that haven't been touched or haven't been used? The whole sector, this one, is not used, it's not touched. So the file slack is actually 512, which is 1 byte. Which is one sector. So if I expand this portion here, I will see that within this first sector, there are area where I store the file, which is 100 byte, and here is 412 byte. This is the RAM slack, and actually the file slack is here. So if I ask you to calculate how much slacks do I have, what is the drive slack in general, in total, how many wasted bytes I have? Can anyone tell me, given the RAM slack, given the file slack, how much waste of bytes do I have?
$412, maybe.
400 is the RAM slack. File slack is 512. In total, how much? The combination of both the slacks, how much?
900, maybe.
Yes,
Yeah,
924. Exactly. 924 called the total slack. Now let's go back to this example. Like this is an example of fat disks. If I have here like a cluster, and here is the end of a sector, and here is the end of the file, this means the space between end of the file and end of a sector is a RAM slack, and the space, okay, the space between the space of unused sector within a cluster is actually file slack. This is just like a demonstration. So RAM slack is a slack between the end of the logical file and the rest of another sector of that sector. So we are dealing with the same sector. Usually the RAM slack focus on sector level, but the file slack focus on cluster level. The remaining sectors at the end of the cluster. Now let's take this example and solve it together. I will go to this example. Okay. Now there is two actually formula we have to understand in order to calculate the RAM slack and the file slack. As I mentioned, RAM slack, usually when I talked about RAM slack, usually I focus on sector level, right? This is what I mentioned. When I talk about RAM slack, I focus on sector level. So to calculate the RAM slack, I will take the sector size. I will then I will remove the file size mod the sector size. While the file slack, if I would like to calculate the file slack here, sorry, if I calculate the file slack here, the file slacks, I'm talking about a cluster size. Usually the file slacks about a cluster level. So I will calculate the cluster size and then remove the number of sector used multiplied by sector size. How this in reality? How can we calculate this together? Let's do this together. So if I say here is that, like, how can I calculate the RAM slack? طبعا given that the file is 600 bytes and sector size is like 512. Number of sector per cluster is actually 12. So if I ask you here, like this is will be given, but this is need to be calculated. These things need to be calculated. Now, what is the cluster size here? The cluster size is actually sector size multiplied by number of sectors per cluster. So it will be, what is the sector size here? Can anyone tell me what's the sector size? I need your
512.
answers. Sorry?
512.
Yes. And what is number of sectors per cluster?
2.
2. It will be how much?
1024, I think.
Perfect. Bytes. So this is the cluster size. It will be this. Now, what about the RAM slack? The RAM slack, usually we are focusing on sector level. So I will take the sector size. What is the sector size here? Can anyone check here? Where's the sector size?
512.
512 minus, what is the file size?
600 bytes.
600 bytes. Mod, what is the sector size here?
512.
512. So it will be 512 minus, what is 600 mod 512? So I will divide 600 by 512 and I will take the remaining. How much here? What would it give me?
88.
The remaining
88.
is 88.
The remaining is 88. Okay. So, yes. Okay. So here, because 600, perfect, will be 88. So 512 minus 88, how much to get? How much? What's the result?
424.
How much?
424. 424.
424 bytes. This is the RAM slack. So we will have this actually
24, miss.
24.
Yes.
Okay. 512 minus 88, 424. Perfect. 424. 424. Perfect. Okay. Now we will do another calculation here. For the file slack, I have here a cluster size. So what is the cluster size here? What's the cluster size?
1024.
1024 minus number of sectors used.
2.
What's the number of sectors used?
2.
2. Perfect. Multiply by sector size. What's the sector size?
512.
512. Perfect. So it will be how much here?
It is the same, 1024.
Exactly. So it will be what?
0.
0 bytes, which means no file slacks, which means all sectors are used and have data. Okay. Now, what about the disk slack? Disk slack is a combination between RAM slack and the file slack. So disk slack is a combination between RAM slack plus file slack. So it will be how much here is like 424 plus 0. It will be just like 424 bytes. So if I take this into a reality, I have 600 and I have 2 clusters. So let's take this example, 600. I have a file, 600, and here is 2. Let's update and see. It says yes, The cluster size is 1024. Yes, this is the cluster size. Here is the RAM slack is 424. Yes, the RAM slack is 424. The file slack is 0. Yes, it was 0. And we will see this. It says that the first sector is utilized. The second cluster is also utilized, but part of it is has data. And the second part is actually a RAM slack, which is the 424. So this expansion is for this actually sector. Is this clear?
Yes.
Okay, we will take another example here. I want you to calculate this and then give me the answer. I will give you 5 minutes to calculate this and then provide me with the correct answer. Write the answer in the chat. So provide me with the answer here of like, give me the RAM slack here. I would like to know the RAM slack. So I would like to see in the chat the RAM slack as well as the file slack. Okay, as well as, yeah. So anyone can calculate the RAM slack. I will see the chats without looking to anything. I will see the chats and I will like the one that provide me with the correct answers, like it would be considered from the participation. So I'll give you just 2 minutes to do that, to provide me with the RAM slack.
ممكن أشوف المعطيات مرة ثانية؟
Sure. It will be here, yeah.
شكرا.
1. Yes, perfect, Rihaf. Perfect. Excellent, Noura. True. So, Rihaf, can you tell us how did you calculate the RAM slack?
First, we got the file stack minus we got the file stack mod sector.
I will keep it
sector
as it
size
is here. It will be
Yeah.
It will be the sector size. How much the sector size?
of 512
Yes.
minus the file size, which is 1200 mod
Yes.
sector size, which is 512.
1200 mod 512. Exactly. It will be
176.
176. Perfect. And then
Which is equals 336.
perfect. Thank you so much, Rihaf. Thank you so much, Rihaf, for your correct answer. Okay. So this is the RAM slack. Now, what about the file slack? Did anyone calculate the file slack? Perfect, Munira, Sukaina, perfect, excellent. Okay, so here also Inas provide me with a file slack. Okay, I will tell you something about file slacks. It's challenging a bit. It is actually, okay. The RAM slack is actually 336, but the file slack No, it's not 1,536. Who can provide me the correct number? File slacks. Excellent, Sukaina. Excellent. Okay, can you tell us, Sukaina, how do we do the file slack? How can we calculate the file slack here? Take in formula. How can we calculate the file slack here?
We will take the total cluster size minus
So we will
the
take the
sectors.
cluster size. What's the cluster size?
The total one, which is 248. 2,000. Sorry.
How did you calculate the cluster size itself? The cluster size that we usually do, the cluster size here. Let me calculate the cluster size at the beginning. Yeah, we need to understand, the cluster size. The cluster size is what? Sector size. What's sector size here?
512.
Yes, multiplied
And
by?
we have 4 cluster. So we will multiply
Exactly.
512 and 4, which gives us 2,048.
2,048. Perfect, right? This is the cluster size. Now, when I said what is the cluster size, I will bring the same value here, which is 2,048 byte minus number of sectors used. Now, here is the point. How many sectors are utilized? I have a file that has 1,200 and my sector is like 512. I should store this file in sufficient number of sectors. So is one sector sufficient to store this file?
No, to find the actual number of sectors, we will set 1,200 divided on the sector size, which is 512. It gives me approximately number, so it's floating. So I take it into 3 because it was 2 point something.
True. So further information is to understand number of sectors used. To understand number of sector use, I will keep it here with different color. Number of sectors used, usually you will divide راح تاخذين يعني مثلا الفايل size divided by sector size وبعدين تاخذينها تاخذين الرقم الصحيح، يعني ما تاخذينها بالنسبة. مثلا الفايل سايز عندي هنا كم؟ 1200 1200 divided by sector size 512. It will be how much?
راح يعطينا 2 بوينت حاجة تقريبا
2.3. This means حاخذها as a 3. I will not take 2.3. إذا أعطاني 2.3 I will take a 3. Minimum I need 3 sectors to utilize this thing. So number of sectors used, it will be 3. What about the sector size here? Sector size.
السكتور سايز راح نعتبر ان احنا اخذنا تقسيمتين كاملين.
Here it's like given information. It's given. Yeah, it will be 512. Now, can you tell me 2024 minus
sector used,
which is
equal to 3 over divided
3 multiplied by 512. How much gonna be?
Yes. It gives us 1,536.
Perfect. And this would be how much?
512.
512 bytes.
Which equal to file slack.
Which equal to
file slack.
1 sector of file slack. So
why
file
did
slack
2048 become 2024.
I'm sorry. Here is 48. Yeah, but it will give me at the end 512. Thank you so much, Rihaf. So it will be 512 bytes, which means kind of one sector of file slack. So I will see here like this one equal one sector of file slack. So it will be here and it will be here. So what is the total slack here? Total slack or total drive slack? It will be the RAM slack plus the file slack, right? Right? Plus the file slack. It will be how much?
848.
Plus 512. It will be how much?
848.
848. So here is the total slack, total drive slack. I will color it with different color, for example. Okay, now let's fit this with the same and we will see how it looks like. So here, the file is 1,200 and I have 4 sectors per cluster. So type here 1,200 and here 4 sectors per cluster. It told me the cluster size is like 2,048. Yes, this is the cluster size. It's like the cluster size is actually 424. True. This is true. So we have 425. The total slack is 484. The total slack is 848. Perfect. And the RAM slack is 336. And the 5 slack is 512, which means equal to 1 sector. So if we can like demonstrate this, we mentioned that how many number of sectors we use, we actually need 2 point something. Okay, so we have 4 actually clusters, but we need 2 fully and partial of 1 sector. So I have 2 full sectors used, with the third one will be partially utilized. The rest will be RAM slack, and this whole one will be a file slack. Is this clear? Do you have any other questions? You need to familiarize yourself with these calculations to facilitate. So now I will give you this example. If you can calculate the results and provide you with the answer for both RAM slack and file slack. Sometimes we don't need 1 cluster. We might need like 2 clusters, 3 clusters, 4 clusters. I will show you an example. I might have a file like, let's say, 5,000. No, I might have like 8,000. It says, okay, you might need 1, 2, 3, 4 actually clusters. Okay, so all the previous example, we utilized 1 cluster, but in this example, we utilize actually 2. We utilize actually 4 clusters. Now, this is an example. I will give it to you just quickly. I want you to provide me with the RAM slacks and the file slacks as well. Write it in the chat without utilizing any tool, please. I will give you 5 minutes.
Miss, can you show me the question?
تمام انتهى الوقت. حشوف مع بعض النتيجة. طيب وين الشات؟ حطيته لها كذا. راح تكون تقريبا just a minute. اوكي. سو رام سلاك طلع معكم كم؟ perfect. رام سلاك 20 صحيح. perfect. رام سلاك is 20. Thank you so much منيرة. It's correct. So this is the RAM slack. Okay. Okay. So Mira, can you tell us how did you get the RAM slack? As she mentioned, it's like we will do the same thing here. So first of all, we will take the same thing here. So we will take the cluster. We will do the cluster size. We will also calculate the RAM slack, as well as the file slack, as well as we do need to know the number of sectors used. Okay. Now, Mira, you calculate the RAM slacks correctly. So the RAM slack is actually how much? Can you tell me?
RAM slack equal 20.
Yeah, how did you calculate it?
First thing, we take the sector size, which is 512.
Yes.
Minus the file size mod sector size.
Yes. The sector size is 512. So if I divide 5,100 divided by 512, I will take the remaining. So I will divide this by this and then take the remaining. How much it's going to be?
492.
Perfect. And the results will be at the end 20. Exactly. طبعا how did you calculate? This is smooth calculations. Like you will divide this by 512 and then take the remaining. The remaining will be 498. Okay, this is the RAM slack. Anyone calculate the file slack? Anyone calculate the file slack? Perfect. Thank you so much, Sukaina. Yes, Inas, perfect. Perfect. So, okay, Sukaina, mashallah, already answered the previous question, so I will give Inas a chance this time. So thank you so much, Sukaina and Inas. Inas, you can proceed. How do we calculate the 3,000, the file slack, which results in 3,072?
First of all, I took the cluster size.
Yes, which is? Yeah, how can we calculate the cluster size? Here,
I take the sector size multiply by sector per cluster.
Yeah. So it will
which
be?
is 512 multiplied by 8, which is 4,096.
Multiplied by sector per clusters. How many sectors per clusters? It's 8. Perfect, 8. It will be how much?
4,096.
4,096.
Yes.
This is the cluster size. How many sectors used?
I take the file, which is 5,100, and divided by 4,096.
No, the sector size is 512.
Oh, yeah.
Yeah, it will be how much here?
It's 1.2.
1.2, which means?
It's 2. 2 sector.
No, dividing 5,000 by 100, it will be different. So if I calculate 5,100 divided by 512, it will be 9 point something, 9.9, which means 10. Is this clear?
Oh, yeah.
Yeah. Now the question is that I will ask you a question here. Cluster size is like this. But actually, how many clusters do we need to use? Is one cluster sufficient to save this file?
No, we need to.
No. We need to what? To have minimum of two clusters to save the file, because one cluster is even lower than the file size. So we need two clusters to save the file.
Yeah.
This means that, like, I will say here, not a cluster size, or the whole cluster size will be how much? Will be 800 or 8,192, because I need to multiply 4,096 by 2 in order to provide me with the with the clusters, with, like, I will rename it this, instead of a cluster size, I can rename it to all a cluster size to make it consistent. So instead of a cluster size, I can say all a cluster size to make it like equivalent with other examples. So here, all cluster size here, I will say all a cluster size, as well as here sector size, I will say all a cluster size. So what is the cluster size? The cluster size is actually 4,096, right? 4,096,
Yes.
right? But what is the only cluster size? I need to multiply by 2, because I need 2 clusters actually, not one cluster, right?
Yes.
Minus how many number of sectors used?
It is 5,000, I think.
No, we already calculated. Number of sectors used is actually 10. This is the number of sectors used.
Okay.
Yeah, perfect, Mira. What's the sector size now? What's the sector size? What's the sector size? It's already mentioned here.
It is 512.
Yeah, 512. Now, how much it's gonna be?
For
Can you multiply
all,
the both
it is,
number?
yeah.
8,192 minus, it is 10. Minus how much? Can you provide me with the answer?
9,728.
No, I am multiplying 10 by 512. منيرة أنت أعطيتيني جواب صح، بس هنا I need your focus.
I mean, I calculated, so I wrote it wrong. It's 5,120.
Yes. So how much it's gonna be? Can you tell me the final
It is
answer?
3,072.
Perfect. 72, right. Now, perfect. We calculate everything. What about the total drive slack at the end? Total drive slack to RAM slack plus file slacks. What about the RAM slack? It will be how much? It's 20 plus file slack, 3,072. It will be how much? What is the total drive slack right now? 33092 bytes. So this example, if I just go back to this, I have
Miss,
here. Yes?
can you explain the file slack again? Why we multiply
By 2?
4,096 by 2?
Yeah, why? Because every time, so the file is 5,100. This is a good question. The file is 5,100. The question is that, is like Okay, the cluster size is actually 4096. Okay, 4096. But is one cluster sufficient to store this file? No, we need more clusters to save this file. In the previous example, for example, here is the file size is 600, and the cluster size is like, the container is like 1024. Can I store 600 and 1024? Yes. So I need just one cluster. So to make it easier for you, I can make it like this, or I can make another thing. Okay, to make it easier for you, I can say number of clusters used. So if I ask you how many clusters we do use, how many clusters do we need? How many clusters? How many clusters? Now, is one cluster sufficient to hold this file?
We have to use 2.
2, exactly. Minimum 2 clusters to store this file. So here, all a cluster size mean number of clusters used. They are the same concept. Do you get my point?
Yes, but what about the 10?
The 10. How many sectors used? What is the file size? The file size is 5,100. What is the sector size? 512. These are given information. I will divide 5,100 divided by 512. It will give me approximately 9.9, which means I should take 10 sectors actually, not 9.9. 10 sectors. Is this clear? Is this clear? Not yet?
Yes.
Yes. Okay. Even here, I approximately, because I can't say I take 2.3 sector. No, I should say 3 sectors. Two clusters, not like, I should not divide it. It's not float, it's integer value. Okay. So yeah, all cluster size, or I can like change the formula. Like another way of like calculating the file slack is, instead of saying all cluster size, you can say number of clusters minus number of sector use multiplied by sector size. I hope now it's clear for you. Like we have conducted several examples, and you need to like to do your homework at home by like practicing this thing. Okay. So here is the example when I have like 5,100 and I have here 8, it will be like this. I need actually 2 clusters, and here is the file slack, and here is the RAM slack. The RAM slack is actually 6 sectors, 1, 2, 3, 4, 5, 6. Okay. So now, after like we have done this one, this is the thing that you worked on, and the demo, the one that I showed you, we will go to the next slides. Okay. So now we will continue talking about the Windows file systems. Actually, we have different Windows file systems. Can anyone remind me what are the Windows file systems? What are the different flavor of Windows operating system or Windows file systems? What are the different flavors of Windows file systems?
The new technology file system and FAT.
Perfect, excellent, Sukaina. Thank you so much. FAT, what else? What else?
NTFS.
NTFS. What else? Okay, today we will focus on both things, the FAT and the NTFS. There is also resilient file system, but we will focus on the FAT and NTFS. Let's start. Bismillah. Okay, so now FAT is like, the FAT file system stands for FAT allocation table. FAT stands for FAT allocation table. And what is the idea of FAT? The idea of FAT is similar to the previous examples. It says that any file is actually stored in a cluster. Okay, any file stores in a cluster. And if we run out of this cluster, we need to allocate the second next cluster. As the example, if we had like 5,100 file byte, actually we divided it into two clusters, right? One cluster wasn't sufficient to hold the whole file. So we had to have two files. And also in FAT file system, it says that sometimes the next cluster might be not free. So we need to store the file in non-contiguous format. So it will be fragmented. If I go to this example, it's like if sometimes I have a very large file, I cannot store it in one cluster. I need to have multiple clusters. If I have multiple clusters, they might be not stored, like this cluster is already stored. This cluster might be next to this cluster. So in terms of addressing, they are next to each other. Sometimes this next cluster will be reserved, will be allocated. It's not free. So we will store the second cluster in different places. We will call it non-contiguous cluster. So this is the address of the first cluster. This is the address of the second cluster. It's far from each other. So we can find them contiguous, and sometimes we can find them non-contiguous, which means they are not next to each other. So when you run out of room for an allocated cluster, operating system allocate another cluster for your file, which creates more slack space on the disks. Exactly. Here I need to allocate like two clusters, and this creates more slacks, right? As files grow and require more disk space, assigned clusters are changed together. And this chain can be broken into fragmented. So we might find the clusters next to each other, and we might find the clusters far from each other. Okay. It is like, for example, if you go to a hotel and you are for a family, and each room in this hotel holds just two people. They might find the room next to each other, or they might have two rooms in different floors, and in the same floor but in different areas. So this means that your location is actually fragmented. You are not within the same location. Now, when the operating system stores data in a FAT file systems, it's assigned the starting cluster position of the file. So the good thing is that usually it's very interesting that the FAT file systems, when it stores the data, it stores the address of the first cluster. The address of the first clusters, and also it stores how many clusters do we need. These are the information that it stores. Okay, so in this example, if I go to the file system, the FAT file systems, I will see two things. The first thing I will see is that how many clusters do I need? So it will says, okay, we will see something called 2, which means, okay, I do need 2 clusters. Not only this, it will tell me what is the location of the first cluster. Here is the location of the first cluster. What about the other second cluster, third cluster, fourth clusters? It will be actually stored in something called data runs. I will show you this in the example. Okay, let's go back here. Okay. So when the first assigned cluster is filled and runs out of room, FAT assigns the next available cluster to the file. If next available cluster is not contiguous to the current cluster, file becomes fragmented. The same example as a hotel. You are 4 people and the room sufficient. The room capacity is just 2 people. This means that you need to take 2 rooms actually, right? Not 1 room. 1 room is not sufficient. So these 2 rooms is like, okay, I have 2 rooms. which means these two rooms can be next to each other. If there is no availability of two rooms next to each other, the receptionist of the hotel will say, sorry, we can't allocate two rooms next to each other. So maybe you and your sister will stay in this hotel, in this room, and your father and mother will stay in different floor with different actually room. So this is kind of a fragmentation. Okay. Now, in fat file systems, if I delete any file, I will give you this example. This is an example. I have here a file stored in a USB. This USB has a fat file systems. Then I decided to delete the file within the file systems. We state that when we acquire data, we might be able to restore deleted data. So if I do the physical acquisition, I might be able to find the deleted data. How? I will see something like this, and I will see a hexadecimal start with this code E5. If I see E5, this means that this is the starting of a deleted file. So I would know that here are some data. I need to understand what are these data, but actually these data are actually deleted data or deleted file. So that's why we mentioned that in physical acquisition, we will be able to extract deleted data. Why? Because it acquires the whole disk drive, which means I will be able to see all the codes, and I will be able to identify that, okay, E5 means deleted in the fat file systems. So back to this example, back to this slide in Microsoft Operating Systems, when a file is deleted, the directory entry is marked as a deleted file with hex E5 character replacing the first letter of the file name. So they keep actually the file name. Here is a file name, but they will add something here, which means E5, which means this file is actually deleted. Data in the file remains on the disk drive, and area on the disk where the deleted resides becomes unallocated disk space. Unallocated, what is the difference between free and allocated? Free means like anyone can use it. It's not been utilized yet. Unallocated means it was allocated and it becomes unallocated. There was a data, but actually it becomes not utilized because there is like it has been deleted and E5 was replaced in the fat file system. If I see any unallocated disk space, this means that it's available to receive a new data from newly created file or other needing more space, or even we can retrieve some information from this unallocated disk space. Is this clear so far about fat file system? Do you have any question?
No, everything is clear.
Perfect. Okay. Now we will continue talking about an NTFS. NTFS is way better than fat file systems in many ways. In many ways. For example, one of the important example is FAT does not just provide me small information about the file, but NTFS is very interesting. Why? Because first of all, it contains information, more information about files, more metadata about files. So it will not tell me whether this file is deleted and that's it. It will tell me if it is deleted. It will tell me if it is corrupted. It will tell me if it is a correct file. It will tell me if the file is actually, when this file is created, when this file has been changed, when this file has been modified, what was the last access to this file. It would give me a lot of metadata that is very useful in forensics investigation. This is number one. Number two, beside this thing, it would provide me with something called control data. What do I mean by control data? What I mean by control data is that like any modification to the files, it is logged and recorded. This means that it provides more control over the files. So actually, NTFS, a new technology file systems introduced in Windows NT and Windows 8, and it's also utilized in Windows 10 and in Windows 11. What are the two improvements of NTFS that's not exist in FAT? It has more metadata about a file. It has more control over files and folder using log file attributes. NTFS was Microsoft's move toward a journaling file systems. What do I mean by journaling? Like if I ask you, some people like take kind of, they are writing their journals, their diaries, their things. So what I mean by journaling here is that everything is recorded. Everything is has information, any changes, any addition, any deletion, any modification, it is recorded within the NTFS file systems. So it records a transaction before the systems carries it out. So if I say I will delete this file, the journaling will mention that, okay, person X has deleted this file, etc. So it keeps journaling of every transaction happened on the file systems. Now here is not for memorization. It is just an information about default cluster size in NTFS disks. What is the general cluster size in an NTFS disks? Here are the information. So if you have a hard disk drive or a solid state drive, and this solid state drive is actually 128 terabytes, this means that the default sector per cluster is 64. And the default bytes per each sector is 32 kilobytes. It's not 512 bytes, it's 32 kilobytes. Okay, so this is like the default settings. If you would like to adjust these default settings, you have to do it carefully. But this is the default settings that ensures like minimum slack spaces. Okay, a minimum slack spaces or disk spaces or disk slack space. Now in the NTFS file systems, there is something called, what I like to do here is that I usually like to say something. And NTFS, it's like kind of a building. Imagine that this is an NTFS. Imagine that this is an NTFS. Okay, this is an NTFS. I will say this is NTFS file system. How the NTFS file systems looks like? The NTFS file systems has two things. Has something called system data, and user data. It has two things, system data and user data. Okay, it has two things, system data. Here's the, let's say, the system data, and here is the user data. System data actually stored in something called master file table. So system data is actually stored in something called master file table. So, and it is actually stored in like 15. So we have 15 record of system data. So I will type here X. It's kind of a building. Imagine a building that has a lot of apartments, or it has a lot of or a hotel that has like a lot of rooms. Okay, so to make it easier for all of us. Okay, so all of this will be reserved for the system. What about the rest? The rest things. Okay, here are the rest. The rest is actually stored for the user. The other apartment or the other hotel rooms are actually stored for the user. For the user. And it might be more, actually. The user will have actually more than the system. So now we have something called master file table within the system. What is this master file table? Master file table is actually a general table. It is not seen for the operating system. It is kind of a secret how the files are stored. What are the files? What are the security controls over the files? It provides a lot of information. So let's see this master file table together. The first record in the first 15 records in the master file table will be as the following. Or I can go here, actually. Yeah. So the master file table contains information about all files on the disks. And it includes the system files that the operating system uses. Okay, yani it's like, do you remember the question when I asked you where is the operating system stored? The operating system stored in the hard disk drive or the disk drive. If I have a bootable from a disk drive, and it's stored in the master file table, and there is a specific attribute called boot where we can store the operating system. In the MFT, the first MFT records are reserved for system files, and it is hidden. The other remaining are for user files. So this is kind of how the NTFS, it has a master file table and how the data are actually stored. Records in the MFT are called metadata. So what are these metadata? So I will show you here, going back to this example. So NTFS has actually a master file table. I will just adjust this information. It has a master file table that contains system data and user data. And the system data is actually only 15 records, or the first 15 records. It will be the first 15 records. First 15 records. So all of this is actually NTFS MFT. So this table is actually called the master file table. This table is actually the master file table. The master file table contains 15 records for the system, and the remaining is for the user. Now, what are stored in the first 15? What are the main aspects in these 15? So they will be called metadata. These are called metadata or attributes. So information about the file. What are these information? Okay, here the first record or the first hotel or the first apartment is called MFT. So I know I am talking about a master file table, and within a master file table, there is a record has MFT. So it is an MFT, and the file name is also MFT. What does this information, what does it record? It records all the information. So here in the MFT, it records all the file records for each. Like, let's say you are using Windows and you have maybe 10,000 files. All the metadata information about these 10,000 will be stored here. So the file name, the file size, the creation, the deletion, all the information about the files will be stored in the MFT record. Okay. Is this clear? So here is the first attribute. The second attribute or the second record or the second apartment or room will contain MFT mirror. What does that mean? They will copy the first 4 records of MFT in the MFT mirror. So if this is corrupted for any reason, we will be able to utilize this to restore the MFT record, because this is very critical. The MFT record is very critical. So if I don't have access to this, still it is kind of a backup if you have a backup file. Okay. So a duplicate image of the first 4 records of the MFT. Now we have something here called log file. What is log file? Log file is kind of like list of transactions happened on the files. Any transactions happened. Do you remember when we mentioned this point? It provides more control. NTFS gives more control over files and folder. Why? Because it provides the log file. The log file is like contains all the transactions happened. And this means that I have more control over the data. I can, all the transactions happened. I will be able to see it. So it loads everything here. Also the volume. What do I mean by the volume? The volume is like, okay, now I have this MFT file. Where this MFT stored? Is it stored in a USB with the name data and a USB with the name volume? Or is it stored in a hard disk drive with a name, for example, the name? The volume means the name. Information specific to the volume, such as label or version, is stored here. So it contains information about the volume, such as the volume label. These are like kind of names. So your hard disk drive or USB has a name. This is the volume, okay? What's the attribute definition? Attribute definition, a table attribute names, numbers, and descriptions. So it's like kind of further information about the files itself. Okay. Also, we have the dollar. Girls, do you know what is the root folder in the Linux? Anyone knows what's the root folder in Linux? Anyone? Okay, so the root folder is kind of like the main folder where I can store all the files. So if I have any file here, let's say I have here, for example, I have this, for example, Kali shared folder. If I go to the, for example, get info, and I will see this is the volume. My volume is Macintosh Hard HD, which means this is the name of my hard disk drive. So what is the root here is like everything starts with Macintosh HD. Then like this is the root folder. The root folder, the Macintosh hard disk drive, which contains all the users and then everything. So if I go to any file here and I will say get info, it will start from the same thing. This is kind of a root folder that contains all my information. All the paths refer to the same, like the first location. So going back to this, okay, so going back to this. Present it again. So a root folder is like the main folder within your file systems. What is bitmap? Bitmap is interesting. Bitmap, it will kind of a map that shows you what are the clusters that are available, what are the clusters that are not available or used. It's like if you go to a hotel, it will tell you what are the rooms that are available, what are the rooms that are not available. It is used. So this is the bitmap. What is boot? Boot is like as in the previous class. Boot store the information about the operating system. Now imagine the file systems contain one record about the operating system. Okay, bad cluster. What are bad cluster? Bad cluster is like attribute in the MFT that results that mention what are the any clusters that is bad. It's like if you are in a hotel and there is, for example, electricity in one of the rooms, the electricity is not connected, or there is مثلا انقطع المويه في احد الغرف. It will not be utilized, so it will be marked as a bad cluster. So bad clusters is areas where it shouldn't be used. And it is different than bitmap. Bitmap, what are the used and unused cluster? Bad clusters that should not store any data because it is bad. What is secure? Secure means for any file stored in the MFT, we will have something called ACL, اللي هو access control list. Access control list, who can read this file, who can access this file, who can, like, it is like if I have here this file, okay, I have something called sharing and permission, but yeah, so I would like, let me, yeah, it's like kind of, it's kind of like what are the sharing permission for each one. So it says that, okay, we have here different users. So for me, I can read and write. For other people, they can just only read. So ACL, access control list, provide the privileges for each file. It is not the job of the operating system. It's the job of the file system. Okay. So security means security description for all files within a volume. Uppercase means any file information, they will be changed from lowercase to uppercase to make it consistent standards among all the file systems. So it converts all lowercase characters to uppercase Unicode character for the NTFS volume. Okay. And the rest will be actually reserved for future use. The same thing, to understand this, I have here example. So here I will have something called MFT, I will have here this one called MFT mirror, and I will have here, for example, log file, etc. And many others, okay? And many others. Okay, now just to simplify it, I have mentioned all of them here and how it is related to a real world analogy. So for example, a log file is like to log all the transaction on a file, who create, who modify, who delete. It's like if in real world, if we have a CCTV cameras and we track who accessed the building, who left the building, who modified something in the building, etc. For example, bitmap shows me what are the utilized and the free and used sectors. The same thing for the hotel. It's kind of a chart that shows me what are the available and non-available rooms, and so forth. So read this, is very interesting to link your information all together. Now let's go back to this. Now we have an NTFS, a master file table. This is the whole master file table. من 0 إلى 15, it is for the system. Starting from 16, we have actually the user. Keep in your mind, when I say the first 15 records, it's included 0. So it is actually 16 records because we start from 0 till 15. So it is 16 records, but they mentioned the first 15 records because the indexing is starting from 0. Okay, now this MFT, we need to focus a lot about the MFT. What is the MFT record? What is this? This is actually stores information about each file. Each file within my disk drive has kind of instant or information stored in the MFT. Okay, and actually the point is that I might, like here it says that every file has 1 kilobyte. Every file has 1 kilobyte or 512 bytes. If a file has more than 512 bytes, it will be stored actually in sectors or in areas. It will be stored, sorry, outside the MFT. So MFT, if I have a file, let's say that here, I'll give you an example. Let's say I will take, for example, this one. I will check the size. get info, and the size. The size is like 1,340.8 megabyte. Is it larger than 512 or less than 512? Are you with me? Anyone?
Less than?
Less? Is it less?
Can you repeat the question?
Is okay, I have this file and it is 1,304 megabytes. Is it larger than 512 kilobytes or lower? Is it larger or less?
Greater than.
Greater
It's
than
in
5.
megabyte.
Exactly. If it is greater than the 1 kilobyte or the 512 bytes, if it is larger, go back here. If it is larger, this means I will store part of the data here and the rest will be here in the user file directories. I cannot store the whole information here. I cannot store the whole information. I'll store part of the information related to the CYS 505. I will start part of the information. This means I will store part of the information here, 1 kilobyte, and the rest will be stored here. Okay, what if I have this example? I have, let's say, this, I have a new file. I have this file. Let's say I have this example or this file, test. I will see the information. It is 13 kilobytes. Is 13 kilobytes lower than 1 kilo, lower or higher than 1 kilobyte? It's higher than 1 kilobyte. This means, yeah, it is higher than 1 kilobyte. This means that I can store 1 kilobyte in the MFT and the rest will be stored in the user file directory. Okay, but if I have a very small file that's less than kilobyte, I will store all the information within here. Okay. Now, let's continue. I will explain this in detail on slide 14. Okay. Now, file or folder information is typically stored in 1 or 2 ways in the MFT record. They will be called either resident or non-resident. Resident means the file and the data, all of them stored in the MFT. For every small file, about 512 bytes or less, all file metadata and data are stored in the MFT record. These types of record are called resident files because all their information is stored in the MFT record. But non-resident, what does non-resident mean? Non-resident means that if I have files that are larger than 512 bytes, they will be stored in outside MFT. If I have file, for example, and this file is, as you can see here, I have this file, the test was like, this test was actually 13 kilobytes. This means I cannot store it in the MFT. I will just store part of the information in the MFT. The rest will not be stored in the MFT. Okay. So anything larger, they will be, the MFT will provide a cluster address where the first file is stored on the drive partition, and these cluster addresses are referred to be as data runs. So this means that I need actually more than like 1 clusters, and they will be called data runs. Any non-resident, they will be called data runs, and we will see example of data runs. So this type of FT record is called non-resident because the file data is stored in its own separated file outside the MFT. Therefore, we called it non-resident. Not all the information, the metadata and the data are stored in one file, in one area. This means it is separated. This means it's non-resident. This means we will have something called data run, and we will explain the data run and the cluster address in, inshallah, upcoming slides. Okay. Keep in your mind that there is 2 hexa values. If I see 00 hexa value, this means it is a resident file. If I see 01 hexa file, this means non-resident file. So if I see 00, this means resident. If I see 001, this means non-resident. And we will see this together. I will show you here. Yeah. So I know this is for you, it's not clear. But the point is that within something called 18, we have something 00. This means that this is actually a resident flag. So I will see the data here, and we can see that here is the data, and this is the data of the file. But if I have here 01, it means non-resident flag, and the data will not be here. It will be in different place. Okay, let's go back here. Now, going back to our example in MFT. Okay, MFT store info about all files in the storage medium. Okay, so we have if size is less than 512, it will be resident. If size is larger than 512, it will be what? Non-resident, right? Is this clear? Are you with me or with the quiz? Are you with me?
Yes.
Because these are important information. I need your focus. Okay. Now, there is something here called attribute, file attribute, okay, or attributes in MFT. So what is attribute in MFT? What is attribute? What is attribute in MFT? We have a lot of attributes. These attributes will be as follows. Okay, we have something called 0x10, 0x20, 0x30, 0x40, 0x50,
Like
0x.
flags,
Sorry?
similar to flags.
Similar to class, similar to a
No,
feature.
flags, I mean.
Similar to what?
Flags.
Flags, exactly. Excellent, excellent. Similar to a flag, okay? And they are, the attributes are named by numbers, but each number means something. 70, 0x80, and many others. So, and many others. Now, these are different attributes. You need to focus on all of them. Okay, you need to focus on all of them. Specifically 80. 80 contains data. So, and these are important information as well. So all of them are important, but 80 store the data. So do you remember when I have this file, the test that contains hi or hello? Okay, this means that the hi or hello will be stored here. The content of this file, what is the content of this file? Here is the content. The content is hi. So I will see the data or the hi, actually I will see it somehow in 0x80. I will see it in the data attribute. Okay, I will see it here. But in 0x30, I will see something related to the file name. And what was the file name here? What's the file name? If you go, what is the file name? Do you see the file name? What was the file name?
Test.
Exactly. Here I will see information about the file name. Perfect. So what other information? Okay. There are other information. So here, okay. So here is like generic information. It's for generic information about the file, generic information about the file. And there is something called MAC. MAC stands for, M stands for modified, A stands for access, C stands for change or created. So all that, like when the file is, for example, modified, when the file is accessed, when the file is created or changed, all this information will be stored here. So generic information about MAC. Okay, so anything related to the file, file creation, file modification, file change will be stored here. Okay, what is 0x20? 0x20 usually it stores like it stores more information or metadata about the file. So if 0x10, if the attribute, I will name it 10, if the attribute 10 is not sufficient to store generic information, we have like more storage here. So this flag can store more information about the metadata of the file. Regarding attribute 30 store information about the file name, not about the file name. And here about the data. I want you to focus about these attributes because we know that we have NTFS, file systems, and there is master file table. The master file table has a lot of like blocks. The first 16 blocks are actually, I have to have actually 16 blocks. So this one, 16 blocks, but it started from 0 till number 15. So here is number, actually, this is number 15, but this is number 0. Just to make it clearer for you. And here are the user data. Within the MFT, I have a lot of flags, including MFT that stores the file information, MFT mirror, a copy of the first 4 records in the MFT, log file, any information that's related to the log, and many others. And here we have something called attributes. Now, I want to mention something. Let's go to the slide. Okay. So here is like attribute ID number. If I have attribute 10, it's standard information. It will tell me, okay, this is the file. What's the MAC? The MAC, if I say here MAC, just to make it easier for you, M means modified, who had modified the file, who has accessed the file, who has changed the file, and who has created this file. So file creation, this is creation, file changes, who has accessed this file, who has modified this file, all information about the MAC, and the file will be stored in the standard information. We have attribute list. What's attribute list? More information about the standard information. So attributes that does not fit in the MFT, it will be stored here. Okay. File name, what is the file name? Attribute 30. It contains information about the file name. File names means that, okay, I have here this file and its name is test, right? What if I change the file name from test to something else, like here I have test and I say rename to quiz, for example, or quiz file name. So this means that in 30, I will store information about the file name. What is the, when this file name was created, usually the creation of the file name is the same creation of the file. When this file has been, when the file name has been changed, when the file name has been modified, etc. It says that usually in يعني there is something called long and short files. In older operating systems, long files names have two IDs. يعني if I, for example, examine older version of NTFS, I will see 030 duplicated 2 times because one of the short name and the other one for the long name. But now in the modern operating system, I will see just one time of 0x30. What is 040? 040 is like kind of like an ID for this file. It's kind of an ID that is يعني unique for all files within the master file table. Also 050 means ACL for the file, so the access control list for the file, who can read, write, modify the file. A volume name of the file, where this file is actually stored, a volume information, indicate the version and the state of the volume, and the data, which is very critical because file data for resident file or data runs of non-resident files. This is the critical thing, and we would like to investigate in this يعني lecture. And there are many other things, but just read them and try to link them with actual example. So now I will show you different hexa files. But before going to the hexa files, I will tell you something that, all information in is actually written in Big Endian. What does Big Endian means? Big Endian is like a format of how the hexa are stored. But actually, in order to make a meaningful information, I should transform this Big Endian into a Little Endian. How do I do this? So I have here the address from 01, I have each 2 digits, each 2 components form 1 byte, and this is actually a hexa value. So it is written from the left to the right, but actually in order to change it to a Little Endian, I have to take the right to keep it to the left, and then 70, I keep it here, 60F, I keep it here, 5E, I keep it here, 4D, and 36, and so forth. So I will bring this one here, and 1A will be here. So this is how it is written, but actually in order to make it a meaningful, I have to change any Big Endian into Little Endian. So for example, if I have 2A, 3B, for example, how can I change it from Big Endian into Little Endian? Can anyone tell me? Anyone?
The 2B, it will be in index 6.
I will just swap them.
We don't have 2A.
I will have 3B, 2A, right, Sukaina?
Yes.
Yeah, it's just kind of a swapping. It's just kind of a swapping. So I will put this here and this here. Okay. Now let's go to this example. Now, do you know when you, for example, let's say I am acquiring my whole, let's say I'm acquiring my whole hard disk drive, and this hard disk drive is actually, I have this hard disk drive, let's say, I have this hard disk drive, Macintosh hard disk drive, and I have done kind of acquisition to my hard disk drive. Let's say I have done an acquisition, okay, of this. And the acquisition, do you see the system data? We have here something called system data.
Yes.
Yeah, the system data is like kind of, if let's say I am using, let's say I am Windows, not Mac. System data means the master file table, okay? And the rest, the documents, application, music, etc. These are what? These are the user data. And here are the like free data. Now, if I have done a physical acquisition of this, if I have done a physical acquisition, what will I be able to see? And if I take the hard disk drive and do the physical acquisition and open it with Hexa-Editor file, I will see something like this. Do you understand anything here? Is it clear for you?
It's a bit confusing, a little bit.
Yes, it is confusing. It is not clear. We don't know what is this actually. It's weird. So here it says that here we have something called file. Do you see the file?
Yes.
This means that there is a file here. There is a file. And this is all a snapshot of one file. So if I have, let's say here, let's say I have 10 files in my hard disk drive or SSD. Let's say I have 10 files. This means I would have kind of like, for file 1, I will have kind of a snapshot or like clear Hexa-Editor, like something in this, something like in slide 17. Something in slide 17. What does that mean? This means that I will see something like this. It's not clear, but I do know that there is a file here. And we will see the things that we call it attribute. Here are the attributes. Do you remember the attributes? When I say the flags? Yeah. Do you remember the attributes? We mentioned that, okay, we have here attribute, the attribute 10, the attribute here 20, the attribute 30, the attribute, many other attributes, the attribute 80. Now we will see after the file, the flags that we mentioned previously, the flags we mentioned. We see all the flags mentioned previously, all the flags, the 10, 20, 30, 40, till 80. Now, after each one, I will like calculate after each one to know the size of each attribute. Each attribute has a size. How can I know the size? I will leave 3 bytes and then take 2 bytes. I will leave 3 bytes, and then I will take 2 bytes. I will leave 1, 2, 3, and then I will take the 2 bytes. These two things, these 2 bytes here, are actually the size of this flag. The size of this flag, the size of this flag. What does that mean? The size of the generic data, the size of the file, the size of the data. So I give you example like 66, like if I tell you like 6000, okay? This is actually in a big endian. I have to change it into little endian. So I have 6000. This is the big endian. I have to change it to little endian. It will be the opposite. So I will take 000 here and 60 here. Then I have to transfer this hexa into decimal. How can I transfer or like convert from hex to decimal? I have to multiply by 16. So I have here 00, which is nothing, and 60. So I will keep here 6 and here 0. I will multiply by 6 to the power of 1 and 6 to the power of 0. It will give me this thing. I will give you another example, D801. Let's take this example, D801. So what is the size here? D801, right? Right? D801. This is the little endian, right? What is the big endian?
01D8.
01D8. Now this is in hexa. I need to transfer from hexa to decimal, because this is a size. I do know, like, I do know what is 01D8 size. I need to give me like numbers and like either a decimal number or an integer number. So I will change it from hex to decimal. How can I change from hex to decimal? I have to multiply this to the power to 6 to the power of 0, this 6 to the power of 1, 16, sorry, to the power of 0, 16 to the power of 1, 16 to the power of 2, 16 to the power of 3. So I will keep this. I will keep all this information. So I have to multiply. So I have here 8. And I have here D. And I have here 1. And I have here 0, right? I need to multiply. I need to multiply now each one with a 16. So I multiply this by 16 to the power of 0. And this one, 16 to the power of 1. And this one, 16 to the power of 2. And this to the 16 of power 3. To give me the value in hexa and decimal, from hexa to decimal. So I will take these values and I will multiply them by 6 by these values to give me the decimal values. Now, can you help me in calculating this? Anyone would like to help me in this? It will be part of the participation, so I need your support in this. Anyone?
I will help.
It's okay, mashallah. She is always active, mashallah, tabarakallah. So any other one, or we'll go with Sukaina? Okay, Sukaina, thank you so much for your for your efforts. Now, yalla, Sukaina. So what is the value of this?
It will be 0.
0. Anything multiplied by 0, it will be 0. No, even to calculate 16 to the power of 13. Perfect. Plus 1 multiplied by 16 to the power of 2. How much it's going to be?
256.
256. 36? 56.
56.
Perfect. D multiplied by 16. What is D in hexa values?
Will we take the ASCII or? I'm not sure.
D is yeah. So yes, it's like okay, we have 0 till 16. So let me see, D, E, F. So D will be actually
13.
number 13. D equal to 13. And
it will give us a large number.
Yes. So D will be
3000
multiplied by 16.
To the power of 1.
To the power of 1. Yes.
It will be 208.
It will be 0 plus 216 plus how much?
208.
208. Perfect. Now let's go back here. 8 multiplied by 16 to the power of 0 means 8 multiplied by 1, right? Because anything to the power of 0 is 1.
It will give us 8.
Perfect. So how much it's going to be at the end?
472.
What is this 472 bytes? So what does that mean? Let's go back to this example. This means that this file, the quiz file that I'm trying to store has, let's say, a size of 472 bytes. And I will see the data here. I will see the data. Here are all the data. I need to see 472 bytes. They will be stored here. Is this clear? This is just the size. We will do the same thing for the 6000 and 8800. Okay, now let's go to this example. This example has 68. So this example, I have here attribute 80. I have attribute 80, right? I have attribute 80. And this attribute 80, in order to know the size, I will calculate 3 bytes. And after the 3 bytes, it will be the size of the data. Now, what is the size of the data? It will be 7801. 7801, this is the big endian. I will change it to little endian 0178. Then it will be actually, in order to calculate it to the decimal, I will keep the 8 here, the 7 here, the 1 here, and the 0 will be 0 actually. Then 16 to the power of 0, 16 to the power of 1, 16 to the power of 2, then it will give me 376 bytes. So I will have 365 bytes of the size of the data. Now, another question is that, are the data resident or non-resident? I need, in order to know resident or non-resident, I need to check the flag. The flag here, as you can see here, the flag is actually 00. 00 means resident. If I see 01 means non-resident. So the flag is actually 00, which means it is actually resident. Okay. Okay. Now I will keep these as they are, and we will continue. Okay. Now, what is this? Yeah. This is an example of non-resident. An example of non-resident, we will see the same thing, 80, and we will calculate 3 bytes, and after the 3 bytes, we will see the size, and then I will see 01. If I see 01, this means the data are not resident. If the data is non-resident, this means I will get some information regarding number of clusters and the first cluster. So here, I will try to see something, a hexa contains either 22 or 21. So I will see something called either 22 or 21. Okay, I will see something. If I see 22, this means that here is actually number of a cluster. 2 means number of a cluster. Number of a cluster that needs to be stored for this data is E01. And this 2 means the first location of the first cluster. And we will explain this later, inshallah. We will see this in example, but just to let you know that here I have resident data. So all the data will be here. But here the data is not resident. So how would I know the first cluster? How would I know the address of the first cluster? How many clusters do we have? All the information will be in flag start with 21 or 22. I see this will tell me. Okay. I think I will stop till here because, and we will continue inshallah next week. We will continue from slide inshallah 21 and we will inshallah take example of we will take example of this. Don't worry. Regarding this, there are many examples here about a data run. I will explain this thing inshallah in the upcoming slides, so don't worry about it. Okay, do you have any question regarding today's lecture?
No, miss, thank you.
You are welcome. I know there are new information from you, but I tend to be slower actually. I don't want to put a lot of information. This lecture, it should be covered in, the whole lecture should be covered in one lecture, but I don't prefer to give all the lecture in one lecture. It is heavy. So I decided to divide it into 2 lectures so you grasp the information easily, and you can interrupt me if you need any questions. I will stop till here. I will upload the recording for you. And if you need or if you have any questions, feel free to ask. I will take just the attendance.